Now in today's video lecture, we'll start the chapter Aldehyde, Ketones and Carboxylic acid. In the previous unit, we have studied when the carbon is linked with single bond to the functional group. Now in this unit, we will study about the organic compounds containing carbon-oxygen double bond. Now aldehyde, ketone, carboxylic acid. Now aldehyde and ketone functional group, collectively they are called as carbonyl group. Here carbon is linked with double bond. Now if one alkyl group and one hydrogen is present, then it is called aldehyde group. If both alkyl group are present, then it is called ketone group. And third functional group we will study in this chapter will be carboxylic acid group. Now carboxylic acid group is the combination of carbonyl group and hydroxyl group. So collectively it forms carboxylic acid group. In this chapter, we also have to study the derivatives of carboxylic acid. Now there are 4 derivatives of carboxylic acid: acid chloride, acid anhydride, ester and amines. 4 derivatives. RCOCl means the OH of the carboxylic acid is replaced by X. So it is called acid chloride. Second is RCO whole twice O it is. When 2 molecules of carboxylic acid undergoes dehydration, it forms acid anhydride. RCO whole twice O. RCO whole twice O. This can be written as RCO O CO R. So this is called acid anhydride. Third derivative of carboxylic acid is ester, R C O O R. The H of the carboxylic acid is replaced by alkyl group. So this group is called as ester. And fourth is, that is RNH2 group. This group is called RCONH2. This is called acidamide group. Means OH of the carboxylic acid is replaced by NH2 group. So here you can see that in first derivative carbon is linked with halogen. In second, the carbon is linked with oxygen. Third, carbon is linked with alkyl group, oxygen then alkyl group, and fourth one is directly with nitrogen. So these are the four derivatives of carboxylic acid. Next, aldehyde, ketones and carboxylic acids are widely present in the animal as well as plant kingdom. In class 10th you have studied that when the red ant bite, we feel pain. So formic acid is produced by the sting of the red ant or the bee. Second is, we have sirka, that is vinegar, and it is acetic acid. Similarly, there are many compounds in the aldehyde ketone group which are well known to us. For example, vanillin. Now vanillin is used to extract vanilla essence, which is the most common essence used in the preparation of the food items, especially ice cream. Second is salicylaldehyde. And third is cinnamaldehyde. CH double bond CHO CH. This is cinnamaldehyde. Now this compound is used as dalchini in our foodstuffs, garam masala, one of the most important ingredient, just like the stick or you can say bark of a tree. Next is nomenclature and structure of carbonyl compounds. First we will study the nomenclature. Now, while writing IUPAC naming of aldehyde and ketone, the carbon of the functional group is also included in the long chain. This is the most important point, that in IUPAC naming, the carbon of the functional group is also included in the long chain. For example, the first member of the aldehyde group is HCHO. In common name is formaldehyde. Common name is formaldehyde. Now, the carbon of the functional group is also included in the long chain. So, this is carbon 1. So, for carbon 1, we will write down methane, and E will be eliminated and the suffix -al is used. So, it is called methanol. Second member is CH3CHO. Its common name is acetaldehyde. But 1 and 2. So, IUPAC name will be for 2 carbon we will write down ethane, remove E and add -al suffix. So, name will be ethanol. Here it will be methanol. Similarly, one more compound you can write down. In addition to aldehyde group, Br is also present here. So, its naming will be 1, 2, 3, 4, 5. So, 5 carbon. So, we will write down pentane, remove E and add -al. It will be pentanol, and at third position Br is present. So, 3 bromopentanol. Now, one more example we can take for the cyclo compound. Now, this is, if we do not consider CHO, then this one is called as cyclohexane. We can remove E and we can add -al, cyclohexanol, or we can also write down as cyclohexane carbaldehyde. Now, sometimes these functional groups have got lower preference, then we can use the prefix oxo collectively for both aldehyde and ketone, or for aldehyde it is called aldo, and for ketone it is called keto. I will give you one example. Now, CH3 CH2 CH COOH. and we can add here CHO group. So at one side aldehyde group and second side is carboxylic acid group. So in order of preference, COOH group got the priority. So numbering will be 1, 2, 3, 4, 5. So for 5 we will write down pentane, remove E and add pentanoic acid. And at the 5th position aldehyde group, so we can write down 2-oxo or 2-aldo pentanoic acid. So both can be used. Collectively we call it as a second example for that is second functional group, ketone. For ketone, the suffix used is -one or general IUPAC name will be alkanone. Now, the simplest compound in ketone is of 3 carbon, 1, 2, 3. So it will be propane, remove E and add suffix O and E, propanone. So its first member, it is in the middle. If suppose the second compound is this, now here we should number from that side from where CO should get the lowest preference. So numbering will be from this side. So here it is. At second position CO group is there, so it will be called as butanone 2. Now one more example we can take, C6H5 CO CH2 CH3. Now at one side phenyl group is there and in second side is ethyl group is there. So we will number it from this side. So it will be 1, phenyl group is 1. So this 1, 2, 3. So naming will be 1 phenyl propanone 1. Now we can take some more examples. In the case of aromatic compound if CHO group is directly attached to the benzene ring, then it is called as benzaldehyde. and if it is nitro group is present, so at third position nitro group is present, so it will be named as 3-nitrobenzaldehyde. Now it can also be called as 3-nitrobenzene carbaldehyde. So both the names are correct. Either you can write on 3-nitrobenzaldehyde or 3-nitrobenzene carbaldehyde. Now sometimes more than one functional group is present, then we write down the number of carbon atom. We do not consider these numbering in the longest chain. So 1, 2, 3 propane, the position 1, 2, 3 propane, tricarbaldehyde, we can also take the example in the case if two CHO group are present in the benzene ring. Now this can be written as benzene 1,2 dicarbaldehyde. Next is ketone we have done. Now carboxylic acid. Third is carboxylic acid, RCOOH. Carboxylic acid general IPAC name is alkanoic acid. The suffix OIC acid is used. Next is carboxylic acid, RCOOH. General IPAC name is alkanoic acid. Now here the first member is HCOOH. First member is HCOOH. So again the carbon of COOH group is also included in long chain. So one carbon methane, and we will remove E and suffix OIC. Suffix OIC acid. So suffix used will be this methanoic acid. Commonly it is known as, common name is formic acid. Second member is CH3COOH. Now 2 carbon. So for 2 carbon we write down ethane, remove E and add OIC, ethanoic acid. Common name is acetic acid. The common name of these acids are derived from their source. Since this methanoic acid is obtained from red ant, its Latin word is formica. Similarly, acetic acid obtained from acetum, so it is called as acetic acid. Likewise, there are many compounds and their names are derived from their natural sources. Now, derivatives of carboxylic acid. First is RCOCl. This is known as acid chloride. Now, acid chloride, again here also the carbon of the functional group will be included in long chain. The first member is COCl, HCOCl, and here the suffix oil chloride, suffix oil chloride is used. Now the first one carbon, so methane, remove E and add oil chloride. It is called as methane oil chloride. Similarly, CH3COCl, 2 carbon, so it is ethanoic chloride. The suffix oil chloride is used. Second derivative is acid anhydride. Acid anhydride, general IUPAC name is alkanoic anhydride. Alkanoic anhydride means oic anhydride is the suffix used. First example, CH3COOCO CH3. Now around O, same number of carbon atoms are present. Therefore, for 2 carbon we write down ethane, remove E and add OIC anhydride. If these two groups are different, then we write down if both the groups present around O in anhydride is different, then we write down the name of both the acids separately from which they are derived. Now if two different groups are present, one side 2 carbon, another side 3 carbon. So we will write down, and this should be written in alphabetical order. So E comes first, so ethanoic, propanoic, ethanoic, propanoic and hydride. Now third derivative is amide, RCONH2. Now general IUPAC name, this is amide, acid amide, acid amide. General IUPAC name is alkanamide, CH3CO NH2. Again, carbon of the functional group is also included in the long chain. 2 carbon, for 2 carbon we write down ethane, remove E and add amide, ethanamide. Now these amide are of 3 types: primary, secondary and tertiary. Now one alkyl group is present, then it is called primary amide. If one of the hydrogen of NH2 is replaced by another alkyl group, then its name is, at this N methyl group is present, so we will write down N for nitrogen, N methyl, and here it is 2 carbon, so it is called N methyl ethana. This is called secondary amide. Next example is, the third is tertiary. Tertiary amide, both the hydrogen of nitrogen are replaced by alkyl group, then its name is, since both are same, so we can write down NN dimethyl, and 3 carbon here are there, so propanamide. And if these groups are different, then we will write down separately N, then N. We can take one example. One ethyl group and one methyl group, then it is called as N ethyl, N methyl propanamide. And the fourth derivative of acid is ester group. That is R C O O R. That is this R is obtained by replacing the H of carboxylic acid. Its general IUPAC name is alkyl alkanoate. Now this alkyl group is the R which is obtained by replacing H, and this part will be considered as alkanoate. We can take the example. We will write down the example. CH3 COO CH3. Now this will be alkyl part and this will be alkanoate part. So it is methyl ethanoate. Now next is structure of carboxylic acid. Structure of carboxylic carbonyl group. Now the carbon here is sp2 hybridized, 3 sigma bonds, are present here, and the bond angle is 120 degree. The bond angle is 100. All the three, the angles are 120 degrees. Now this bond is pi bond. The orbital of carbon is overlapped with the orbital of oxygen. So this forms pi bond. Now in this structure we can see that oxygen is more electronegative. It attracts this bond and it forms C plus and O minus. Now the carbon acquires positive charge, it behaves as Lewis acid. This carbon is electrophilic, and the oxygen acquires negative charge, so it behaves as Lewis base, and it is nucleophilic. And the bond is polar in nature. It has net dipole moment and have high polarity. So first, this structure is the neutral, and the second structure, this is bipolar. Now in today's session, we have studied about the introductions of aldehyde, ketone, carboxylic acid, then its IUPAC name of aldehyde, ketone, carboxylic acid and their derivatives, and the structure of the carbonyl group.